Now we talked about what prefix, postfix, and infix is. Sometimes you might see Polish notation and reverse Polish notation as well as prefix and postfix. Now what we want to do is how we get from infix to prefix or postfix. So if we look at this, a plus 4, we can see that easily what we want to do is move the operand to that edge or the operand to this edge, depending on if we're doing prefix or postfix. And it seems very easy. But if you have a more complex document, it's harder to do. Now, there are multiple ways of doing this. I'm going to show you my way, which I think is the easiest way of doing it. Alright, so if you have a plus 2 minus 4x plus 7 squared. Now what we need to do is first convert everything so it's very explicit what's going on. So there's an operator in each location. We have the 4x, which really doesn't have an operator, and we have the squared, which doesn't have an operator, something we can move. So what we're first going to do is we're going to do a plus 2 minus, and then we're going to do 4 and put the explicit times in there, plus 7, and we're going to do a caret 2. So we now have an operator for the exponent. And then all we're going to do is use our PEMDAS and go through and explicitly put in parentheses wherever we would do them. So of course we would need a parentheses here, and of course for the exponent we need parentheses there, and then we need parentheses around each one. And then all you need to do is move the operator. So if you're doing prefix, every left parenthesis has to have a operator next to it, and if you're doing postfix, every right parenthesis has to have an operator next to it. So what we're going to do is we're going to move the plus over to there, we're going to move the minus over to there, we're going to move the times over to there, the plus over to there, and the exponent over to there. And if we do that, we end up with left paren minus left paren plus a2 right paren, and then we do left paren exponent left paren plus left paren times 4x right paren 7 right paren 2 right paren right paren. And now it's in prefix notation. Notice that these are next to one another. There's nothing between them. So that, if you think about in a computer, they would be in a different memory slot. In here, you're not sure if it's A2 or A and 2. So writing it is a little more difficult or confusing than if it was in the computer, where every one of these signs would be in a different memory location. Let's try another one. But let's go to postfix. And for postfix, we do almost the exact same thing, just opposite. So for postfix, we move the plus sign there, we move the exponent there, we move the plus sign there, we move the multiplication sign here, and we move the minus sign there. So we end up with left paren, a2 plus, right paren. And then we do left paren, 4x times right paren, 7 plus right paren, 2 exponent, right paren, minus time, right paren. And so that's postfix. Let's try another one. So if we have 2x parentheses 3 times r, and let's raise that to the third power. So again, what we first want to do is go for and add the explicit operators in. So that's going to be here and here. So we're going to do 2 times x times the 3 times r exponent 3. Don't forget there's a multiplication implied here and here. And then we go through and we put the parentheses in as if it was PEMDAS. So we come across and we do the multiplication, we do the exponent, and then we do the final multiplication. And once we have all the parentheses in, it's a piece of cake to move it. If we're doing prefix, we do 1 to there, 1 to there, 1 to there, and wait, no, yeah, 1 to there, and this one goes there. So we end up with left paren times left paren times 2x right paren, left paren exponent left paren times 3r right paren 3 right paren right paren. And if we were doing prefix, we just move them the opposite way. And now we do this to there, this to there, this to there, and that to there. You never change the order of anything. You're just adding parentheses and moving operators. The operands never change their order. So we do left 2x times left 3r times right 3 exponent right times right. So far so good. Let's try another one. Let's do a division this time. So if we do 1/3 plus, oh, let's be crazy. We're going to do 7 divided by 3x times 4. So again, we want to make this explicit. So we do 1 divided by 3 plus 7 divided by, and of course, to do this right, we're going to have to put a parentheses in, 3 times x times 4, and then that parenthesis. And then, of course, to make it really explicit, we have to put the parentheses in there, the parentheses there, and then don't forget the parentheses there. The other thing to realize is the parentheses should match up with each operator. You should have the same number of sets of parentheses as you have operators. And then, of course, we move them. For prefix, it's going to be, that's going to move there, 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 and that's going to move there. So we're going to end up with left plus left divided by 1, 3, right, left divided by 7, left times 3, left times x 4, right, 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 right. So let's check that. We have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5. So the left and right matches. And that's all there is to infix, prefix, and postfix. Now the interesting thing is, this was developed before computers, but it was actually the first handheld calculators. You had to put in the punch in the numbers just as we were doing here. You would write the equation down and then convert it into usually prefix and then put the prefix in. Sometimes it was postfix, but usually it was prefix. So you had to do this to get the calculator to work, which just shows you that that's how the computer solves it. Anytime it does a mathematical equation like this, the computer first, the compiler first converts it to either prefix or postfix before it is calculated. And that's what we're going to work on this week.